Alright, now we're going to look at speed time graphs. Previously we were looking at distance time graph. So same thing, we're going to understand what happens as we go along the line. It's a different story. So for example, as I go along this line, you know that time is passing, it's increasing. 0 to 2 to 4 seconds, so on and so forth. But what happens on the y-axis as we go along? We notice that the y-axis value, the speed, also increases. So as time passes, the speed is changing and it's increasing in this case. So what does this mean? It actually means, yes, there is acceleration. Speed is changing as time passes. So there's acceleration. Okay? In this case, actually, the acceleration is constant. Okay, so now you might be thinking, okay, how do I find the exact number of the acceleration? So similarly, I can do it by the gradient method, okay, which is to use y2 minus y1 over x2 minus x1. Okay, so in this case, let's find the acceleration from this point to this point. So I'm going to mark it out as a coordinate 2, 3. Here is 0, 0. So 3 minus 0 over 2 minus 0 to give me 1.5 meter per second squared. Or I could use it by the physics method to have final velocity minus initial velocity over the change in time. So what is the final velocity from here to here? Yes, it's 3. Initial velocity, starting velocity, 0. And how long did this process take? 2 seconds. And you realize that yes, I get the exact same value, no matter if I do it by the maths method or the so-called physics method. Now, last one. You can actually find one extra thing from this graph, and that is actually the distance traveled. Okay, and how do you do that? It's actually the area under the graph. So this actually can be done in two ways. You can actually split it up into a triangle and a rectangle, or you could just simply recognize that this is a trapezium. So a trapezium area is found by this formula. So what are my values of A, B and H? A and B are the lengths of the parallel sides. So from here to here, it's a length of 2 to 4, right? And from here to here, 0 to 4, so it's 4. So half times 2 plus 4 multiplied by the height between the two parallel sides, which happens to be a value of 3. So with that, we have 6 times 3, 18, and I'm going to get a distance value of 9 meters. And that's it. From a speed time graph, I can find the exact acceleration of an object, finding the gradient in general, and I also can find the distance traveled by an object by finding the area under the curve.